All right, let's dive right into this explainer and look at the most absolutely unforgiving environments on our planet. We're talking about places so wildly alien and hostile that just stepping foot in them is a monumental feat of engineering. You know, the crushing depths of our oceans and the freezing stretches of our polar ice caps are totally critical to understanding Earth's overall health, yet they remain some of the least explored areas in existence. Picture this. You plunged thousands of meters down into the deep ocean. You're suddenly dealing with crushing atmospheric pressure, literally freezing temperatures well below what our bodies can handle, and just total, inescapable darkness. It's an environment where human survival is basically impossible, with heavy, complex, and let's face it, incredibly expensive life support systems. So to understand how we actually overcome this massive physical challenge, here's our survival guide for today's explainer. We'll start with exploring the extreme, move on to what is an ROV, unpack the tech under the surface, look at real-world ocean missions, and finally explore the MATE ROV competition.
Okay, Section 1. Exploring the extreme. Let's look at the vast scale of Earth's most hostile regions.
The sheer scale of this challenge is just massive. Consider the cryosphere. That includes our planet's polar ice sheets, sea ice, and permafrost. Get this, the cryosphere covers roughly 10% of Earth's land, but it stores about 70% of the world's fresh water. That means the vast majority of our drinking water is locked up in regions that remain incredibly difficult to study. In fact, it's such a big deal that the United Nations endorsed a decade of action for cryospheric sciences just to push for more research here.
So, the big question we really have to ask ourselves is how on earth do we study an environment that actively repels us? If we can't physically send a person safely under shifting polar ice, how do we gather the scientific data we so desperately need? Which brings us to part 2. What is an ROV? Let's meet the robotic avatars of the deep.
An ROV, which stands for Remotely Operated Vehicle, is basically a tethered, unoccupied underwater robot. It's hooked up via a long cable to an operator who's sitting safely up on the surface. Honestly, it's essentially a robotic avatar. It lets us safely project our physical presence into these alien environments while we're standing comfortably on the deck of a ship.
When you stack human divers up against ROVs, the contrast is pretty stark. It totally makes sense why robots don't need hot cocoa under the ice, right? Even with the most advanced diving suits, our biology just can't withstand the deep ocean's crushing pressure for long. But an ROV? Extreme resilience. Their capabilities completely blow past our fragile limits, working tirelessly in sub-zero water without ever needing to come up for air. Let's move to Section 3, Tech Under the Surface, and break down the anatomy of an underwater explorer. It's definitely not just a waterproof box. These machines are absolute marvels of integrated tech. Every ROV relies on a few essential parts. You've got the tether, which acts like an umbilical cord for power and real-time data. Then you have thrusters for propulsion, high-def cameras and sensors, manipulator arms to actually grab things, and buoyancy control systems to hover perfectly in the water column. It's this beautiful harmony of fluid power and electrical systems.
To really grasp how hard this is, imagine trying to thread a needle in the freezing dark while wearing a blindfold. That's exactly what deep ocean visibility is like. Zero. That's why tools like the Omniscan 450 FS imaging sonar are complete game changers. They use high-frequency sound pulses to literally pierce through murky freezing water, acting as the vehicle's eyes when normal cameras completely fail.
Okay, Section 4, Real-World Ocean Missions. This is the ultimate proving ground for marine technology.
Let's see this in action. For example, researchers out off the coast of Newfoundland, Canada, which has some notoriously brutal marine conditions, regularly use ROVs. They actually just use them at the Funk Island Deep Marine Refuge to map these incredibly rare, densely populated cold-water coral gardens. Without ROVs down there, those fragile ecosystems would just remain totally undiscovered.
They're also super vital for high-stakes tracking missions. Out where massive icebergs roam, operators use these robots to predict their path. It's a precise process. Step 1, survey the iceberg's perimeter. Step 2, dive down to measure the iceberg's keel depth. That's the massive chunk of ice hidden underwater. And Step 3, evaluate the threat levels to subsea oil assets. And we're talking about multi-billion-dollar infrastructure here. Places like the Hibernia, Hebron, Searose, and Terra Nova platforms. Those underwater iceberg keels, they are basically giant frozen battering rams. Getting accurate keel depth data from an ROV allows engineers to make absolute life-saving decisions for these offshore platforms. We also deploy these really specialized autonomous floats right under the polar ice. They run on a super strict timeline to stay alive. At 0 minutes, they drop in vertically. At 15 minutes, they ascend to a specific depth. By 30 minutes, they hold position to collect chemistry data. And crucially, by 60 minutes, if they sense solid ice above them, they initiate an ice avoidance sequence, diving back down so they aren't crushed, and they only transmit their data when they finally hit open water. So smart, right?
Finally, Section 5, the MATE ROV Competition, how we're building the workforce of tomorrow.
If this tech is so incredibly vital, who's going to build it tomorrow? Well, I absolutely love this quote from the MATE ROV Competition Manual. Think of yourselves as entrepreneurs. It perfectly captures the vibe. These students aren't just in a robotics club. They are literally operating as real-world startup companies solving the exact challenges we've been talking about today.
By tackling these real-world missions, mapping corals, monitoring icebergs, these students develop a crazy good array of hard and soft skills. I mean, this goes way beyond just wiring a motor. We're talking complex system design, dialing in vehicle buoyancy, and sensor integration, all while leveling up their creativity and critical thinking. They actually organize themselves into corporate roles. You've got a CEO leading the vision, a CFO managing the budget, R&D innovating, system engineering building the bot, and even marketing and media outreach making sure their message lands. It is literally the ultimate hands-on prep for a modern STEM career.
So it's abundantly clear that the extreme environments of our planet desperately need exploring. The data hidden down there is an absolute game changer for our future. And thankfully, because of dynamic programs like the MATE ROV Competition, the next generation of engineers and scientists is already gearing up. So I'll leave you with this. We have the technology to reach the bottom of the ocean today, but what extreme frontier will they conquer next?